Let's make it happen. Okay. I'll share my screen.
Okay.
Okay, let me know when you can see it.
I can see it.
Okay, great. Just think of here. All right, so today's topics, assertions, do-while statements, switch statements, and then we're going to do one problem on multidimensional string problems. And since we have kind of a small crowd today, we'll just go through the problems and I'll walk through the solutions, but I won't necessarily stop and have like a 10-minute break because you can't do the questions. So
Okay.
if you're watching the recording for this video, just pause the video after I introduce the question, work on the problem for a little bit on your own, and then and then come back and watch my walkthrough. So as always, you can do your coding on the playground. Also want to quickly advertise the EMP mega thread that we have posted. We like continuously post on here. So if you guys like want to watch our videos or vote for the next topics, you can on the EMP mega thread. Yeah. Okay, first topic, assertions. So assertions are kind of Java's way of checking if things are working as they should. Perhaps it would be better put if we said they are there for you to check if things are working as you want them to. They're kind of Java's handy little tool that you can add in and check if the function that you created or the code that you wrote works correctly. So they're really for using, they're really used for test cases in your code. And they take kind of a conditional form. So this is an example of assertion. And the conditional form basically says, I want you to assert that the response from this piece of code, this array, will return 15. The assertion basically ensures that if it isn't 15, it kind of throws an error. It asserts that it's 15. We know that the answer from this call to sum should return 15. So it's a test case essentially. So if it's not 15, then we know that this function is wrong. It's doing something incorrect. Similarly, if you call sum on the numbers 0, -1, 5, and 8, you know the answer should be 12. So the assert, it basically ensures that this sum is returning the correct thing. So think of it, I see a lot of students getting it mixed up a little bit when they're writing their assertion statements. The assertion statements they're written in a way that they should be written in a way that encourages them to be true. Like you want to write the assert 12 equals sum. That's what you want to be true. You don't want to write it in a way that it's untrue. You don't want to assert that sum of 0, -1, 5, and 8 is equal to 8. You know, that doesn't make sense. You want to write them in a way that makes sure you want to write them so that they're true. So I'll show you in a bit what that really means. Let's keep going. So here is the first practice problem on assertions. So the basis of assertions really comes from like test-driven development. When we're creating code and different pieces of functions for applications and machine learning models, et cetera, you really want to write things so that you can test them and they pass the tests all the time. So that's what we mean by test-driven development. You write code and you test it, and you continuously test it, and you write several test cases for your code and to make sure that it's working correctly. So here's a problem. We are creating a function called count, and count basically takes a string that looks like this, and it also takes another string that looks like this. And you basically need to count the number of times that this word appears in this string. I imagine that most of you can probably do this problem pretty easily. It's just a string problem. What we're asking you to do is create a bunch of assertion statements that will test to make sure that this particular function does what it should do. And what you really want to make sure when you're answering this problem is you want to make sure that you're covering all the edge cases. So what are edge cases? Sorry, I have sort of a
Okay.
so weird. So edge cases are really just small, I guess, variations in code that could cause the code to fail. Some sort of like extreme situation that rarely happens, but it could happen in the code. So for this kind of problem, the extreme or rare situation that could happen is that you pass in a null here, you pass in a null here, or this is an empty string and this is an empty string. So in those situations, your code will function a little bit differently than it normally would. It wouldn't just be you counting all of the cashews in the string. If this was null, then you couldn't count the number of nulls in the string. You can't do that. So that's what it means by like accounting for edge cases. So your assertion statements should have a bunch of examples that are kind of normal situations where count works properly with two strings. And then you should have a bunch of examples with the nulls and also empty strings. And so this is probably the point which I'll show you the starter code. This is the starter code. Your test cases or your assertion statements should go down here, and your code for count should actually go up here, how you want count to function. I've described it for you already, so now you want to write up the code for how you want it to work. I recommend writing out the test cases first, commenting them out, and then writing your code for count and seeing if count correctly passes all your assertion test cases. So yeah, if you're watching the recording, you can go ahead and pause the video here. Try to work this out on your own. I won't stop or pause because we've got kind of a small crowd today, and I want to utilize as much time as possible to walk through the solutions. All right, so okay. All right, so first what we want to do is we want to create some assertion statements. Okay. So let's save this thing here. Okay. And I'm just gonna comment this out for now so it doesn't give me any weird errors. Okay, so if you have the function count and you have a string, you have a string sentence and a string word. What's an example string that we can put in here? Just anything you can think. Ideas?
You are the best.
Okay, yeah, we can put in you are the best. That's a pretty normal sentence. And then maybe we can count the number of times that best occurs in count. So if this is one test case, we want to write our assertion statements to say assert that this count would return 1. This is something we want to be sure that's true. We know that if you run count needs to return 1 in this specific case. So that's kind of the normal case. Normal case. Okay. So how about an abnormal case? What would be that example? So in this slide, we had mentioned some of them. One is empty strings. So empty strings. Okay, so you want to assert that something is true. We don't know what that will be yet. Count. So if you have, let's just use the same string before you are the best. But now you're searching for an empty string and you are the best. There is no empty string in here, right? So what should the assert return? Or like, what should we assert? What should go here?
Maybe no.
No, I mean, I suppose you could have it check for empty string and then just return null. But remember that this function returns integers. So what integer would go here?
Zero.
Yeah. Okay, and then alternatively, you could also have empty string show up over here, right? You are the best could be the empty string case too. So assert count, oops, and then we have an empty string, and now you're checking for best inside of an empty string. But best doesn't exist inside of empty string, so you know that you want to assert that count empty string best is equal to 0. Okay. So now the
Okay.
last case is the null case. So in the null case, since we're returning an integer, you probably just want to return 0. Because you just don't have any nulls inside of these strings. And we know that count needs to be returning the number of this word inside of this sentence. So you really can't count the number of times the actual Java object, or not Java object, but the Java keyword null shows up in a string. You can count the number of times that the string null shows up in a string. And I can show you what that means. So like you can assert that count with you are the best and null, you can assert that this is equal to 0 because you can't check. Really, this is not a string, right? Null is not a string. So you can't count the number of times null shows up in this. So you know it's going to return 0. And then here's the other null case. Oops. To assert 0 equals count. So if your sentence is null, you can't count the number of times that best occurs in because it's null is not a sentence. So in that case, you would also return 0. And what I was referring to earlier, if you had null as a string, so for example, if you said count you are null. So in this case, null is part of this string. So this is not null, the Java keyword. It's just null, part of a string. In this case, you can search for null, the string inside of the string you are null, and you can get null. Okay, so those are your test cases. So now let's quickly type up the code for count. First, I'm going to type up the code for a normal occurrence. So a normal case would be two strings. You get two strings, and then we're going to add the edge case conditions in. So I'm going to create an array called words, and it's going to be splitting the sentence based off of the spaces in the sentence. And so now you have an array of words based off of the sentence. And then you're going to initialize a count that equal to 0. And then you're going to iterate through the array of words, we'll just call them W in words. And then if W dot equals words, so if the current word is equal to this specific word, then we want to increment count. Okay. Oops. Okay. And then at the end, we want to return the count. So let's comment these out because I don't want to get errors. Here's like the normal case that we're testing for. So if this code works, then this assertion statement should pass and nothing should happen. Oops, turns out I have textile problems. Okay, so it worked, nothing unusual happened. If I had asserted that this would be for 2, it's giving me an assertion error because it's saying that you asserted that count should have returned 2, but you actually returned 1, so you have an assertion error. So now let's continue typing out count. If sentence equals null, that's the other case, or sentence or word equal null. Oops. Return 0. So if either one of these are null, you just want to return 0 because you know you can't go through all of this stuff. You can't split a null, you can't split a word. I mean, you can't split a null. This was null, word was null. So that worked. So let's just I comment our test cases. Whoops. So what does that look like? Is I'm missing something? What am I missing? Okay, so now all of our assertions passed. We have no errors. Our code is complete for this first problem. Any questions before I move on? I know I'm moving kind of slowly today. Okay, great.
No questions.
Okay. So now we have the do while statements. This is, I think you guys are learning about this in today's lecture also. No, you didn't. You already learned about this, I think. So do while statements,
Yes.
yeah, are similar to just like regular while statements, except for the fact that you always have to run the while statement at least one time. And these are incredibly uncommon in the real world. but some people still use them. They are kind of like a common programming practice in Java and other languages. Some people say that it's bad practice because you really can do what a do while loop does with while loops, for loops, et cetera, et cetera. They're just not very elegant. And some people would say it's bad practice. So up to you if you decide to use it, but I think they make things more complicated. So here's our first practice problem. Okay. So in this code, so basically, you really don't need to worry about what this code returns. But what you need to understand how it works, though. You don't need to understand all of this stuff, this random util stuff. You learn about that later. But the basic gist of it is that you're going to run this request web page several times. And the request web page will basically return true or false based off depending on if the web page was successfully retrieved or not. And you can call request page web page at least 10 times. If you call it more than 10 times, then you basically want to print something else, okay? So what you need to do is design a do while loop that will call request web page and continue to call request web page until you've called it either 10 times or you have managed to call it successfully one time. And so this is kind of going to be your basis for your do while loop and what it should do. And I will now walk through the solution for this. So people who are watching the recording, you should go ahead and pause here and try this out on your own. I'm gonna go ahead and move to that solution. Okay, so I'm gonna copy this in just so that we have a reference. Okay. So let me walk through this part here. So you want to create a do while loop that keeps track of the number of attempts to the request page. So you want to have a variable for attempts. And you'll want to have a variable for whether you are successful or not. Success. Okay, so you have a Boolean variable called success equals false. So initially you haven't tried it out, so you're just setting it to be false. So now you want to create your do while loop. Do while. So you want to run this at least one time. And when you run it, you want to increase your number of attempts by 1. And then you want to call request web page. Okay. And request web page will return true or false depending on what the logic it has. You don't need to worry about the logic. But this will return true or false. That tells you whether the web page request was successful or not. So if it was successful, it'll return true, and then you can set success to be true. Was not successful, you can return success to be false, and it was not successful. So in your while statement, what should you be checking for to make sure that this runs properly? Because we said that the request, you continue to run until the requests are either successful or unless we've tried it 10 times. So what should we have in this statement inside of the while loop?
Greater or equal to 10.
Yeah, so you want to make sure the attempts is actually not greater than 10, but you want to make sure that you want to continue running the loop while the attempts is less than 10. So once you hit 10, you want to make sure that it's just 0. And here, just to make sure that everything's working properly, I'll just add a system data and when attempts, okay. And what's the other condition? We want to stop running this loop when what happens? Or we want to continue running the loop if the attempts is less than 10 and while what should this return? What should success be in order for this to continue running? Any ideas?
The remainder is equal to 0.
Well, it doesn't return that though. It returns whether it's true or false, whether it was successful or not. So we want to continue calling web request page if the web request is true or false.
Is false.
Yeah. So if web request was not successful, then you want to be continuing to go. And after 10 times, if we're still not successful after 10 times, we want to just return, not return, out something, system out current and you fifth. Okay. 25. Understand. Oh. If not successful, oh, you're not the semicolon. Okay. Right. So, I mean, this will pretty much on the 0th run it'll end up working correctly, but let's say this is 7. 7, sorry, not 7. Let's do 6. Oh, it's just, sorry, it's just using a random. I don't know why it mattered. Yeah, that is nice. So do 0. And it's just continuously retrieving the web page successfully. And it just does it 6. Just do it 0. Okay, so here it ran 0 times, so attempts was still 0, and then attempts increased to 1, and then the web page was unsuccessful, and so then it tried again. And in this attempt, it looks like it was successful. So here, if we run it again, so this outputs kind of whether it was successful or not randomly. That's what's happening here when we're calling all this stuff that you guys are unfamiliar with. But because it's random, you never know how many times this do while loop will run. But you can only run up to 10 times. So yeah, that's how that works. Any questions? I know this is kind of a complex problem.
Nope.
Good. Okay, great.
Yes.
Yeah. So let's move on to switch statements then. Yep. So switch statements. This is a topic that you guys covered today. Am I correct on that? Yes. So switch statements are part of today's lesson, but they're super easy. They're kind of like if statements, but they're a little bit cleaner depending on how you look at it. They're also not very common. I haven't seen them used a lot, at least in Java. But they just let you do different things based off of the condition of some variable, essentially. And so there's some keywords that you have to know, which is like case, break, fault, defaults, this arrow sign, and yield. The arrow sign and it kind of says this is for like this arrow sign is I don't think that's a substitute for break statements, but I guess you could use it as a substitute for break statements. The arrow sign basically says if the case is this, then just this is what you should return. You can use a break too, and if you go through this lecture, you'll see different examples of it. Here's the general syntax for what this looks like. So you have the switch is the first part of it, and then you have day, and then you have day is like a variable here, and yeah, and based off of what day is, you have different conditions. So if in the case where day is Monday, you kind of just do nothing. If the case that day is Tuesday, you don't do anything either. On the case that date is Thursday, you print something out and then you break out of the switch. Similar thing here. So I think what he meant here when he said substitute arrow as a break is you could use an arrow here and then you could say system.out println party and then just exit. So here's the practice on switch statements. We'll do 5 minutes. How does that sound? And yeah, for people who are recording, just pause, and watching the recording, just pause and you know, go through the problem on your own. But we will go through it now. So we're going to be converting this if statement here into a switch statement. So you can use either. We really don't see switch statements that often, but I think some people might think this is more elegant. So I'll work on this. So here's the statement. Okay, so we have to create a switch statement out of this. So you need the switch word in the beginning. And here we're going to be using this. It seems that situation is kind of the variable that we're looking at for this switch, because if you notice the if statement, it's just going through and looking at what situation is, and based on what situation is, it returns something. So switch situation. Okay. Okay. And so inside of the switch, you have a bunch of cases. So in the first case, if switch is morning, then what you want to do is you want to use this arrow sign to return true. And then here's the other case. If switch is afternoon, then you want to return false. And in this case of switch situation is evening, then you want to return false. And if the situation is cramming, then you can also return as true. And then you can have the default, which is kind of like the else statement. Default, in the case of default, then you can just return false. Yeah. So if situation is none of these things, you want to return false. Okay, so yeah, this is the converted version of the if statement. I guess it's a little bit nicer to look at. You don't have all these ors and stuff, and equals, that equals, and everything. It's kind of clean. You know exactly what each of these are going to do. And you can actually make this situation. So this situation will output either true or false. So you could actually set this Boolean equal to make coffee up here. And you can, at the end of the switch, you could just do system dot out dot println make coffee, like so. Yes, let's run it. Right, don't forget semicolons at the end of this stuff. Why am I getting a bunch of textiles? I think. Okay, so now it's working. Morning should return true. If this was cramming, or evening, actually, let's do evening. If it's evening, then it should return false. So it does a lot of the same things as an if statement, just a little nicer to look at, I guess. So those are the main topics for today's section. There's one more problem on multidimensional string problems. Before I get to that, I forgot. Are there any questions on the switch statement stuff?
No.
Okay. All right, so we've got a couple of minutes. So we'll go ahead and review the multidimensional string problem. So this is the setup for the problem. So you're supposed to write a function that goes to a string, a 2D array of strings called tweets. And so in this tweet string array, you have the first dimension is kind of the name of the person, and the second dimension is their tweet. And so what you have to do is you need to simplify the tweets so that there's no punctuation, and then they're lowercase. And then you have to loop through each of these and replace the tweet if it contains a banned word, basically. And then return the sweet tweets. So here's the starter code. So I'll copy this over. Okay, so let's quickly look at the starter code and figure out what's happening here. So you have this function called print tweets that just prints out all of the tweets in your 2D array. You have a function called ban tweets, which is what you're going to write. And you're going to take each of the tweets and you're going to take out the banned word, or I think the banned word is banned word, right? Oh, okay. So the banned word is what you're, yeah. So the banned word is what you're passing into banned word. So you're going to take out this banned word from this tweet. And so this is the array. This is an example of the array. So each of these represents a student or a person, and then you have the person's name, and then you have their tweet. And so you got to figure out how to filter them, call banned tweets and filter them, and then call print tweets. Yeah. So let's try out how to do this. So first and foremost, you know you're going to need to loop through the array. So at this point, you guys should be pretty familiar with this. It's your typical for loop structure. You're going to do this, and you want to get the person's tweet. So now you're at one person, and at that one person, you need to get their tweet. Or we're just gonna call it words because it'll be confusing if we use tweets. So we go through tweets, and then we have ith tweet, and you get the first value from there. And then you're gonna split that based off of these spaces. And I'm gonna add a flag called ban. So now you want to loop through each of the words in there, inside of that, and false. Okay, and then for every string class in words, sorry, not in words, if the s dot equals the banned word, so here's banned word, then we want to set ban equal to true. So we know that ban is equal to true. Okay, so if the tweet is banned, then you want to take that person's tweet, and you're gonna make it now equal to remove, like that. And so at the end of the for loop, you're gonna return tweets. Okay. Yeah, let me make sure that covered everything. Okay, so earlier I think I had said that we should replace the words with the banned word, but I think what we're supposed to do is if there's a banned word in it, then you need to replace the entire tweet with remove, because as you can imagine on Twitter, if you see something is banned, then they're gonna ban the entire tweet, not just the word. So that makes more sense. So let's see what happened here. What am I missing? Token error received at if ban. That's correct. Oh, Okay. Got some check style errors in here. Just going through them now. Make sure I didn't mess something up. Oh, too bad. This should be a string, not a string array. I'm sorry. This should be a string array, not a string. Cannot find symbol. Filter tweets. Filter. Doing tweets. Oh. So now it's working. So in these first two tweets, you have the word day, so they're removed in the last one. That looks good. So they're not removed. So that's the gist of this problem. I thought this was a pretty fun problem. I hope you guys enjoyed it. We're right on the mark, 7 o'clock. I really encourage you guys to practice this kind of on your own. It'll be really helpful, I think. Yeah, so that's it. Do you have any questions? Let me know, and I'll stick around for a little bit if you do. Yeah, have a good weekend, I guess. Fill out the feedback form. Yeah.
Okay. Have a
Yeah.
good weekend.
Yeah, you too.
Bye.
Bye.